We'll deal here with satellites, and that too at length. When the satellites revolve, obviously they must be having speed, angular momentum, kinetic energy, potential energy. So one by one we go into detail. First, let's discuss angular momentum. Angular momentum, is given by m₁m₂. If you put the value of this velocity, that is root gme upon r, it becomes m root gme r, angular momentum. It's depending on mass of the big object, or you can say the earth. It will depend on the size of earth and that of the radius of the orbit also. Means size of the orbit, size of earth, the two sizes are important, whereas the mass of earth is important in angular momentum. Since centripetal force here is because of the gravitational force, and that is towards the center, since the gravitational force is providing the centripetal force and that is towards earth, it becomes a radial force. Radial forces do not contribute to torque. That means torque here by the gravitational force produced will be equal to 0. And overall angular momentum will remain conserved. Then we'll discuss energy at length separately. Suppose the radius of the orbit of satellite is r and its mass is m. For Earth, you are already aware the values me and re. Potential energy of satellite will be given as this thing, the potential energy. Here r is the radius of the orbit, and if you find the kinetic energy using the relation half m₁ square, you see you'll find plus half gme_m upon r. See, they have one very interesting relation. This is minus and this is plus half. If you combine them, that is k plus u, you'll find total energy, and that will come out to be this much. Total energy is exactly equal to kinetic in magnitude, but the nature is opposite. You might say E is equal to minus k. At the same time, potential energy could be said as 2 times total energy, or even you can say E is equal to U upon 2. In terms of total energy, you could say total energy is equal and opposite to kinetic. Total energy is equal to 2 times that of half times that of potential energy. Then see, when the total energy comes out to be negative, it gives some special meaning. Total energy being negative is very, very required thing. It's desirable for everyone. You should never aim at having zero energy, because that time you are free and you might be moved by anybody, any forces, whatsoever may be the value. So total energy should always be negative for every object in order to be stable. Here also total energy is negative. That for satellite it means it's not free. It is bounded by certain forces. In order to make it free from the orbit, you will need this much amount of energy in positive. That's why the 2 will make the whole energy equal to 0. So what becomes binding energy? Binding energy is exactly the energy required to make a body free. That goes true for the satellite also. If you give satellite this much amount of energy, exactly same, but with positive sign, this becomes the binding energy of satellite. Once again, I'll repeat that energy required to make a satellite free from the orbit. It simply means that it will escape now because it has become free. Now, we have discussed regarding energy in detail. You must know one more phenomenon associated with satellites. In satellite, there is always the state of weightlessness. We are here slightly tilted from the vertical position. The weight creates a moment and becomes cumbersome for you to maintain this inclined position for a longer time. But when the weight is nowhere, weight is not there, any position, you might stand like this and you might stand in this position also, that will make no difference. In satellite, there's no weight. So if a person, see, this is person is standing on the ground. If you just raise him up and make him horizontal, leave, it will remain where it is. That means the weight is not functioning there. If you leave a coin on water surface, it won't sink. If you immerse the rubber ball inside water and leave, it won't come upward because there is no upthrust. That is because of the weight. So all the properties related with the weight will be missing there. There it is very difficult for the astronauts to even drink water, because once you pour the glass this way, the gravity brings the water down. There, the only method to consume, to drink, to eat is through the paste tube. We just simply push the tube and the force presses the things inside the mouth. So other properties are also there. Once you say it is weightlessness, all the properties while falling, you see, when the body in a stone is falling on the earth under the effect of gravity, it is there also in the state of weightlessness because weight is doing some other work. So you may compare the situation of astronauts inside the satellite with the free fall.